Alright, so today we're going to talk about 5.2 trigonometric functions unit circle approach. So basically, how do we use the unit circle to find trig values? So remember, the unit circle is a circle with a radius of 1, and you can see that in this picture right here. And you notice in this picture on the right that I have a circle drawn and I have a triangle drawn. So I know that it has a radius of 1, so that's going to be my hypotenuse for any triangle that I were to draw in any quadrant. Now my y value is the value going up and down, and my x value is the one going left and right. Now you probably remember cosine is x and sine is y, but we're going to see where that comes from our sine and cosine ratios that we talked about all the way back in Math 2. So you probably remember something called SOHCAHTOA. We're going to bring that back for a second. So SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So cosine, it says cosine equals x, but where does that come from? So if we look at our cosine, or CAH, we know that cosine is adjacent over hypotenuse. So we're always looking at what we're going to call theta, which is our angle on the inside closest to our origin. So if we look at the adjacent angle to that, that's going to be x over my hypotenuse is 1, and x over 1 is just going to equal x. We can do the same thing with sine. Sine is opposite over hypotenuse. Well, opposite of theta is going to be y over my hypotenuse is 1, and that leaves me with y. So tangent, if you remember, is y over x. We also talked about it as sine over cosine, and I'm going to show you where that comes from. Now you notice it says x cannot equal 0, reason that being we can't divide by 0. And we'll talk about later on in this unit where those restrictions come in, what happens if x equals 0. Alright, so I'm going to go ahead and erase that. Alright, so let's say we know tangent is opposite over adjacent. So what is opposite of theta? Opposite of theta is y over x is my adjacent side. Now, again, we wrote that on the previous video as sine over cosine because you notice sine is y and cosine is x. So you might also see it written that way. Now, cosecant, depending on when you took Math 3, who you took Math 3 with, you may have seen this, you may have not, but cosecant is the reciprocal of sine, okay? So how could we write that? Well, instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. Okay, so the hypotenuse is 1 over my opposite is y, and we could also write that as 1 over sine of theta. Alright, cosecant is the reciprocal, or secant, sorry, is the reciprocal of cosine. So that's going to be hypotenuse over adjacent. So my hypotenuse was 1, my adjacent was x, and you can also write that as 1 over cosine of theta, since we know cosine of theta is the same as x. Lastly, we have cotangent, and again, y, my denominator, cannot equal 0 because we can't divide by 0. This is also the reciprocal of tangent. So that would be adjacent over opposite. My adjacent is x. My opposite is y. So I would write that as cosine of theta over sine of theta. And you notice that this is just flipped from tangent. So remember, reciprocal just means you flip it. Okay, so now we're going to practice with this a little bit. Alright, so this kind of gives you kind of some basic angles. So I'm going to go ahead and draw a picture. These are your quadrantal angles. So remember we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Well, knowing that x is cosine and y is sine, if I asked you to find, and I'm just going to write these in degrees for right now, so 0, 90, 180, 270, and we know this would go back to 360. If I asked you, for example, to find the cosine, I'll write this over here, the cosine of 90 degrees, well, I would go up to 90 degrees on my unit circle, and I'm looking then for the x value, because that's what corresponds to cosine. So what is the cosine of 90 degrees? That would be 0. And the reason this is important is because you wouldn't have a calculator for something like this. So you can't just type it in your calculator and find out what the answer is. Okay? So let's do something let's do one that you have to divide. So tangent. So tangent of 0 degrees. So we know tangent is sine divided by cosine, or y over x. So that would be 0 over 1, which is 0. Now you notice at 0 degrees, if you look in your chart here, that tangent is 0, but cotangent is not defined. Well, let's talk about why. So we said that cotangent was the reciprocal. So instead of y over x, I would have x over y. So instead of 0 over 1, I would have cosine divided by sine, which is 1 over 0. Well, there I run into a problem because I can't divide by 0. So 1 over 0, we say that's undefined. So anytime you end up dividing by 0, you're going to have an issue there, okay? So you can't divide by 0, and that's going to happen anytime you're having a cosecant where sine equals 0, or a cotangent where anytime your denominator is going to equal 0, okay? All right, so here's an example here. It says find the values of all 6 of my trig functions if this is a point on my unit circle. All right, so first let's just sketch this here. All right, negative 1/2 square root of 3 over 2. So x is negative, y is positive. So that means I'm going to be in my second quadrant. And I'm going to be over here because I know my x is smaller and I'm going to have a tall triangle. So I'm going to be at, let's see, 30, 60, 90. I'm going to be at 120 degrees. I'm just going to label that negative 1/2 square root of 3 over 2. It's a little messy there. Okay. So again, how I got that, I'm in my second quadrant because x is negative and y is positive. And then I thought to myself, well, that's a bigger y value, so I know I'm going to need the tall triangle there. All right, so sine of t, cosine of t, tangent of t. I always go ahead and I line up, so sine is the reciprocal of cosecant. So if I have to write all 6 of my trig functions, I line them up like that. Secant of t and cotangent of t. Get rid of that little typo there. All right, so sine. Well, this one's pretty easy because sine is always just my y value. So that's just going to be square root of 3 over 2. Cosine is pretty easy because that's just my x value. So that's negative 1/2, and that's given to you from your ordered pair. Now tangent, we're going to have to do a little bit of algebra here because that's sine divided by cosine, or y divided by x. So square root of 3 over 2 divided by negative 1/2. Okay, so what I'm going to go ahead and do, so divided by negative 1/2. So what I'm going to go ahead and do is I'm going to do keep, change, flip. And that's going to turn into square root of 3 over 2 times negative 2 over 1. So keep your first fraction the same, change division to multiplication, and flip your second fraction. So I can cross out the 2's, and I get negative square root 3 over 1, which is just negative square root 3. Okay, Now, what I would do is I would not try and repeat all this algebra here, okay? So cosecant is just going to be the reciprocal of sine. So all you're going to have to do is you're going to have to flip your sign, okay? So it depends on how, I'm going to let you leave radicals in your denominator, okay? However, you need to be able to rationalize in case a multiple choice is given to you with radicals not in the denominator. So I'm going to show you what that looks like for this one. But in the future, if I give you a free response, you don't have to rationalize. So I flip sine to get cosecant. So 2 over square root 3. So again, for our sake, that's okay. But I'm going to remind you how to rationalize that back from unit 0 in case a multiple choice question is given to you where it is rationalized. Okay, so again, to rationalize, I'm going to multiply top and bottom by square root of 3, and I get 2 square root 3 over 3. Okay, again, I'll let you leave it as 2 over square root of 3. I believe the SAT, when I talked to Mr. O'Malley last, will let you leave it as square roots in your denominator. But you should know how to do it. All right, negative 1/2, when you flip that, it's a negative 2. And then this one, so it was negative, remember there's really a 1 on the bottom. So that turns into negative 1 over square root 3. All right, again, you can just leave it like that, but we're going to rationalize on this example. So that turns into negative square root 3 over 3. And that's it. All right, so we have one practice page of going over the unit circle and how to use it. Okay, so flip over to the next page. All right, so here's how I approach these sorts of problems. 2 pi over 3, I always give myself a sketch first. So I'm going to go ahead and draw out the unit circle, and I'm going to find 2 pi over 3. So what you might want to do is kind of sketch out 1, 6, 2, 6, 3, 6, 4, 6. So this is where my point is going to be. Now, this one's pretty easy because it's the exact one we just used in the previous example. So I know my ordered pair is going to be negative 1/2 square root of 3 over 2. All right, so I am going to just go through the math really quick, even though we just did it on the previous example. So cosecant is the reciprocal of sine. So what is my sine value? It's square root of 3 over 2. So instead of square root of 3 over 2, it's going to be 2 over square root of 3. And again, from now on, I'm just going to let you leave those radicals in your denominator. All right, next example, we're going to sketch. So first of all, you notice on this one, it's 6 pi, so that's too big. So if I go one lap around, whoops, that's 2 pi, all right? I go another lap around, that's 4 pi. And if I go another lap around, that's 6 pi. So I'm going to end up at, and I just lost where I was, I'm going to end up back on the far right side. Okay, well, what's my ordered pair there? Well, I went over to the right 1, and I went up 0. So my ordered pair is 1, 0. All right, so secant is 1 over cosine of x. What is my cosine value? My cosine here is 1, because that's my x value. So 1 over 1 equals 1. All right, cosine of negative pi over 3. All right, so this one's a little bit trickier because you have to go backwards. So negative pi over 3. So remember that's 2 6. 2 6. Okay. So normally 2 6 would be up here because 1 6, 2 6. But instead of going up, I'm going to go down. So negative 2 6 or negative 1/3 would be down here. All right, so now we have to figure out your ordered pair. So this guy should be your tallest triangle down here. Now notice your x should be positive and your y should be negative. So my ordered pair down here should be 1/2 negative square root 3 over 2. Okay, because remember that's your tall triangle. It's the one that's the tallest. Even though you're going down, it's the tallest here. And it's just looking for your cosine value, which is the x. So once you get there, you don't have to do any math. It's just 1/2. All right, last one here, tangent of 5 pi over 6. So you're almost halfway there, because remember this over here is pi. 5 pi over 6 is going to be right here. All right, so what's the ordered pair here? So this is your short triangle, so the x is going to be bigger than the y, and it's a negative x and a positive y. So negative square root 3 over 2, positive 1/2. All right, now tangent is sine over cosine. So 1/2 divided by negative square root 3 over 2. Keep change flip. 1/2 times 2 over negative square root 3. So negative 1 over square root 3. And again, you can leave radicals in your denominator. All right, now we have a little bit of algebra here. Okay, so sine of 45 degrees, and if they're back to back, we're multiplying by cosine of 180. So first 45 degrees is going to be right in the middle. Now if you remember, the ones in the middle will always get that middle value, and they're always the same. So square root of 2 over 2, square root of 2 over 2. So the sine is the y value. This one, it doesn't even matter, they're the same. So my first value here is square root of 2 over 2. All right, cosine of 180. 180 is halfway across. Now my ordered pair there, I went left 1, so that's negative 1, and up and down 0. Cosine, I'm looking for the x value. The x value there is negative 1. So I'm going to end up multiplying this by negative 1. If I multiply by negative 1, it's just going to be the opposite. So negative square root 2 over 2. Okay. All right, tangent of pi over 4. So 1/4 is going to be in the same place as 45 degrees. You're a fourth of the way there. So again, square root of 2 over 2, square root of 2 over 2. Now, tangent of pi over 4. I'm not even going to do any algebra with this. So sine divided by cosine. Anytime that I divide two numbers that are the same, 5 divided by 5, 1,000 divided by 1,000. If you divide two numbers that are the same, you're going to get the same number. Or sorry, you're going to get 1. Let me say that one more time. Anytime you divide two numbers that are the same, you're going to get 1. 1,000 divided by 1,000 is 1. 5 divided by 5 is 1. So tangent of pi over 4 is 1. Minus sine of 3 pi over 2. So remember, this is 0, 1/2, 1, 3/2, and 2 in terms of pi. So 1/2 pi, 1 pi, 3 pi over 2, and 2 pi. So 3 pi over 2 is going to be down at the bottom, and my ordered pair there is 0, negative 1. Sine is the y value, so that's going to be negative 1. So I end up with 1 minus negative 1, which is going to end up being 2. All right, so next one, secant of pi over 4. I'm going to take, I just did the ordered pair of pi over 4, so I'm just going to take that from the previous example. Now secant is 1 over cosine. So that means I'm going to have to take cosine, which is square root of 2 over 2, and just flip it. 2 over square root of 2. Now it does ask me to take secant and square it. So instead of 2 over square root of 2, I'm going to have that twice. Okay. All right, I'm going to go ahead and multiply that out before I get any further. So 2 times, I multiply straight across when I'm multiplying fractions. 4 over 2, which is 2. So 2 times 2 is 4, square root of 2 times square root of 2 is 2, which simplifies to 2. So this guy right here just equals 2. All right, next one, I have cosecant of pi over 2. So that's up at the top, and that's going to be 0, 1. Cosecant is the reciprocal of sine, which is 1. So 1 over 1 is 1. So 2 plus 1 equals 3. Okay. All right, last example. It's very similar to the one we did on the previous page. Okay, so very first thing we're going to do is draw kind of a coordinate plane. It says 4, -3. So 4, -3. Alright, so 4 and -3. Alright, so we need to find all 6 functions. So sine of x, cosine of x, tangent of x, cosecant of x, secant of x, and cotangent of x. Now you notice we have a problem because we don't have our third side. However, this is a right triangle and we know how to find the third side of a right triangle using Pythagorean theorem. So we have -3 squared plus 4 squared equals c squared. 9 plus 16 is 25. And so c is going to equal 5. Okay, so anytime you have two sides, you should be able to find the third side of your right triangle. So sine is opposite over hypotenuse. Remember, theta is your angle touching the origin. So opposite is -3 over your hypotenuse is 5. So -3/5. Cosine is adjacent over hypotenuse, so that would be 4/5. Tangent is opposite over adjacent, so that would be -3/4. Cosecant is going to be the reciprocal of sine, so that's going to be -5/3. Secant is the reciprocal of cosine, 5/4. And cotangent is the reciprocal of tangent, -4/3. And that concludes the video on how to use the unit circle.